Hello students, welcome to Solve classes. Today we will be solving the ISI Mmath question paper of year 2016. Today we will be solving question number 27. In question number 27, it has been said that if function fx is defined by e to the power minus of mod of x upon max of ex comma e to the power minus x, where x belongs to the real number set. In that case, option A, f is not continuous at some points. Option B, f is continuous everywhere but not differentiable anywhere. The third point is f is continuous everywhere but not differentiable at exactly one point. And the fourth point is f is differentiable everywhere. So let's start with solving the problem. Now it has been given that f of x is equal to e to the power minus of mod of x upon max of e to the power x e to the power minus x. This is what we have been given for x belongs to real number. Now let's try to draw the graph of e to the power x and e to the power minus x to get some more clarity. Now e to the power x is somewhat like this. This is e to the power x, and similarly if we try to draw for e to the power minus x, e to the power minus x will be somewhat like this. It intersects here at x equal to 0. This is e to the power minus x. So this is what we have got. Now let's get back to solving the problem. So if x is greater than equal to 0, in that case f of x can be defined as e to the power minus of mod x can be written as e to the power minus of x, and as x is greater than equal to 0, we see that e to the power x is more than e to the power is greater than e to the power minus x, as x is greater than equal to 0. So the maximum value of e to the power x and e to the power minus x will be given by e to the power x for x greater than equal to 0. And if x is less than 0, in that case the numerator will be given by e to the power minus of minus x, and for x less than 0 we see that e to the power minus x is greater than e to the power x. So we can write that the maximum value will be given by e to the power minus of x. Now if we solve this will come down that fx will be equal to e to the power minus of 2x for x greater than equal to 0, and e to the power, this will be x e to the power 2x for x less than 0. Now if we try to draw the graph of this function fx, this will give us for x greater than 0, fx is defined by e to the power minus of 2x. So this will be given by this is given e to the power minus of twice x, and e to the power 2x for x less than 0. So this will be given by this portion here, the value here it is from this is y-axis, this is the x-axis, and this is the curve for f of x. So as you can see that f of x is continuous throughout, but at x equal to 0 we can see that here there is a kink point, or we can write it as sharp point. And we always know that at sharp points the function is not differentiable. So we can say that f of x is continuous throughout, but f of x is not differentiable at x equal to 0. So the statement that we'll be looking for is that f of x is continuous everywhere but not differentiable at x equal to 0, and this satisfies the option C. It is not differentiable at exactly one point, which is the point x equal to 0. So the option C is the correct option. So today we have solved question number 27 from the ISI Mmath paper of year 2016. We will be solving the next questions in the subsequent videos. Till then, keep watching Softwares Classes videos for more solutions and content. Thank you very much.